Hello friends, welcome on the channel of Software Engineering World, and today I have a small tutorial for you that covers iterative, or how Google calls it, non-abstract system design. And in this video I will walk you through the steps of this iterative system design to illustrate you the approach, how to do that. We'll use just a small but meaningful part of the order system of typical store. As you see, creating an order and handling its payment. That's all, nothing else. The idea here is not to design the complete production-ready solution, which of course a big system with just few steps, but just to demonstrate you the methodology of iterative improvements that many system design using and many architecture designer use it for their work. Many details here are intentionally left out to keep things clear and focused. Why iterative design matters? So, system design inherently iterative. In real life, you rarely build a robust production-grade system in one go. Instead, you start with minimal design and evolve it step by step. Each iteration reveals weakness and improvements, opportunities that will be nearly impossible to foresee at basically all at once. So here we will have small example of order system uh, that basically every engineer can create from the scratch. And it's very simple. Basically, we have just one server, one database instance, and that's all. And payment gateways that in most cases, it's a third-party service that we can use. So our work is to design systems that basically do these steps. User make order, get payment link, pay by this link. When money on the account, we update the database, of course, saying that order paid, and then go into dispatch. If for some reason user didn't get the payment or basically left the website before pay, we send him a payment link in the email, and in the same way we send him payment succeed email when order paid. That's all, nothing else. Of course, in real system you will have like tons of different steps here. Besides this one, different checks, fraud checks and things like that. But that left out of our like space today. So what we will do in the first step, creating a simple, basically the simplest solution that can work at least somehow. So we have user, we have API web server, we have database here. So user creating order, we basically update database with idempotent record, saving this order in the database. Then we return payment URL in the same response to the user. If for some reason this payment didn't get to the user or user didn't pay it, after some time, some cron jobs that running on the server or some like, for example, in Go language, some callback with timeout running and checking that if payments succeed from the database. If no, we basically send an email to the user with payment link, after which it basically go into the payment gateway and make a payment. Of course, if he won't. The same way we can basically drop order record after some time if user don't want to pay. If everything okay, we get payment callback here from payment gateway to the same server, and basically sending success email to the user. And as you understand, that's approach the simplest. It's basically some POC, for example, and that's not production-ready system. Why? Because we can find different problems here, and to find these problems, we need to ask some questions to ourselves. For example, if server died before email sent, do we have some process, for example, that save status of the if email sent or not on the server, or do we check in the database to get this cron job running? One question. Second, if the server died before payment timeout called, so the same. If we need additional processing after some steps, so for example, we want to add some fraud check somewhere like in the middle of that, and doing this in such architecture design will be hard because we need to update code here, which implies different problems that can arise with that, because amount of code will grow on the same server. This will basically create a bottleneck of all our activity. Another way, if the payment succeed, for example, but we miss the callback or something happened and we didn't update the database that user paid an order. Then we get a problem with user because money goes to the payment, but user didn't get the order. And such question can be a lot, especially in real case design. And that question is a good starting point you to understand what problems you have and fix it one by one. So it's hard to imagine whole system at once and understand all weaknesses of that system. And that's why you need to start from a small one, to go step by step and fixing all this stuff. Because in such way, it's much simpler to see them than trying to get the whole big system and then saying just you have like many different issues here. Very simple to miss some of them, which will basically create a problem for business. And that's why we have iterative design. So we move to the step 2 with additional improvements here. So to not lose, for example, callbacks, we have basically the same API server here that using most of our requests. But now when payment gateway sending callbacks to us here, we don't update database, we don't do anything, we just log this to the SQS or different or other queues that you may use, and it's stored here. So even if something go wrong with our API server processing or something like that, it already stored here. Also, it updated not from the API server, but from the special worker or, for example, Lambda function or similar thing, which imply retry if something misses. So for example, if our callback will fail on this worker, we'll try with another try. If for some reason, for example, after 10 times of repeat, it still fail, we just go it with dead letter queue and saving this callback for further manual, looking for it or other additional processes. Another thing is that we add check for payment if it already paid by user. Why we add it? Because there are situations when user already paid, for example, payment, but for some reason, for example, it forget it or it get additional email payment link when like timeout and payment very close to each other. And for some reason, user trying to pay second time. And thing here is that at that time we didn't get callback still, but payment already processing on the payment gateway, and thus we don't have updated records that it was already paid because we're still waiting for the callback. And if we, for example, give ability to user to pay, if the payment gateway doesn't have additional check for that, Many payment system has a check, but some of them not. So you shouldn't rely on payment gateway as a like verified thing in case if it not align with your policy for system design. So we add check to the payment gateway, basically asking it if the user already paid that order. And if yes, then we're saying that order already paid and basically still waiting for the callback. Also, we move out this email processing to the additional worker or Lambda function, which basically run in outbox pattern or SQL state machine. It's basically very similar thing. Outbox pattern is just very limited version of state machine, basically. And if we look on our whole design, it's basically whole design of this order is basically state machine for this order. So there is no, there shouldn't be a possibility when states of your order is have like disalignment. And for example, you can send payment before you do like previous steps of the order. So basically you have whole this system is a state machine. What is outbox pattern, or what many call it transaction outbox pattern? It's basically when we save in our record and event in the same transaction. So idea here is this: when you, for example, run an update to the database and then trying to like update, for example, second database or second service, you basically have situation when you updated database, but after that you failed. And your data partially updated because one service updated, another not. So in such case, you should manually revert the changes in database that you updated, or use some way to prevent such situation. And transaction outbox is basically one of this pattern because you basically save in two records at once, your updated record and, for example, some events that you then process with your worker, for example, to send email. In our current situation, we don't use another record. We just use update different states for the our order, like sending payment link or payment link succeed, or payment email sent or not, with count and timestamp to understand an amount of repeat, an amount of time that we need to wait before sending second time, for example, like that. So this handled by the worker that basically calls the SQL database, set logs on the records that updated on the worker, and then remove that logs if it updated and change the status of the record. In such way, we basically answered on many questions and fix many of them. For example, what if the server died before email sent? It's not possible because if it died, then we repeat this try. If the server died before payment timeout called the same way, we just repeat. If payment succeed but server died on callback, we have SQS queue that will handle all the stuff. For example, we can remove call to the API server here and, for example, use some additional Lambda endpoint here that accept callback and just save into the SQS. That's all. Or even like save it not in SQS but in some log, for example, using wall log for that, and then sending to SQS if we need additional like support for our availability. Also, if user paid but we sent with a mail payment in and he trying to pay it second time, we have this check here to prevent such situation. Additionally, we can add additional check, for example, from the front end or like mobile application when user clicking the button to pay. For example, having like payment session. So if you don't handle in this payment sessions and you have only one try, for example, and wait for another, something like that. So there are different ways how to check this. The simplest is just to use API of the payment gateway. Almost all payment gateway have API, because in other way it's very hard to connect API server to them. So we just check it directly by direct call. But still, such system already have like production ready and will work fine. But if we want to additional processing after some steps, or we have many steps, or we need dynamic routing of the steps based on, for example, user data or types of orders on all different things. So it doesn't matter. Then it will be harder to add here, because we still rely on the adding API server, doing some modification of our routing, and that's not a good thing because it's imply big changes. So to make this happen, we move to the third version of our design, which of course a little bit bigger. So as you understand, it's just a small part of our architecture, and it already like not very small. To make happen adding additional processing and simplify it, we will use event-driven way of architecture. And here we basically describe every step of our order, first of all as an event with some payload, and the second basically as some function or like worker that should process it. We can have like per function way, for example, using lambda with just one function for one event, or we can use some group of function in one worker that can process different events, grouped by logic, business, domain, or anything else. So here we're using basically the same way how we did with the callbacks here, but basically implies that for all our events. So what we changed here, we use event-driven. The simplest way, for example, on AVS to use event-driven architecture is to use SNS and SQS. What's the idea here is that SNS is basically publish subscribe, when you basically one instance publish and many instances can subscribe on the event and get it simultaneously. And SQS is basically handling storage of such event in case that some fail, something happen, and we need to retry, or for example, say event if we limit it with retry count and it still didn't go well. So SNS is our basically message hub that we use, and then each worker has its SQS queue that's saving all these events. And we link SNS and SQS directly. There is possibility to do such in AVS Cloud, which making infrastructure much simpler. Also, we can add sagas here. Sagas, it's a logical way to cover a transaction in event-driven system. Idea of the sagas is basically loop of the event. So for example, create order, pay order, order succeed, and return back. If on some steps we get fail, we basically return fail back. If some steps succeed, then in the end we return succeed. In such way we can understand if order like should be rolled back or not. Additionally, we need additional steps to cover events on removing, for example, some data or some changes. Because if different steps rely on that, then each of that steps should get event to roll back the transactions that they made for original event. But that's additional thing. I will leave a link in the description on sagas and other interesting things that you should know about event-driven way. So here we're basically doing what? We're still using the same idea. So user created order, and then it pulling our API server to get order status, because all this stuff is, as you understand, running asynchronously. So we can't handle connection here. We can use WebSocket, for example, for that, to simplify, or streaming events from the server. It doesn't matter how way, or just pulling with each request. So user waiting for status of the order. So API server sending events that order created, then it processing it, creating events that order already created, sent to the SNS back. It's sent to the another SQS that need to log inventory, for example, send back. Then we send it somewhere to generate payment. Payment generated, then user gets status that awaiting payment. Payment sent to the user. User paid here, basically to the payment gateway. Another check for if the user already paid that. We get callback to the same status. Callback go to the SNS, to the SQS inventory payment callback here. Sorry, it's not inventory, it's payment, but doesn't matter. We processing it, updating the database here, saying that order paid. It goes here. If order paid, then we send email that order succeed. Also, we have worker or lambda function also that control timing if user didn't pay the email still. If not, we still, like in the previous step, send an email with a payment link. Idea here is that if you need to change your routing for some way, each worker can create different event on the output. You can add additional worker and SQS to the system and just modify how it should accept events, basically what on each event this worker should do. For example, it can run asynchronously or it can run synchronously. Synchronously, I mean in the order of all this stuff. But you must understand that there are some things that you can run asynchronously in the order way, I mean. So things that don't wait for some specific state and transition, but whole architecture of your event driven way should be basically state machine. If it's state machine, then you will not have problems with understanding what's happening. If it relying just on tons of asynchronous code, then you will have problem in most cases, because you don't understand which step going after each step, and there could be problem because of that. So you should control this very carefully. So most of your infrastructure should use in state machine way and have order. So each state should be in a specific position in whole the loop, not in random. But something you can set randomly. I don't know, for example, sending some notification. So this worker doesn't output any new events, so it's not creating additional events to the system. And we basically don't rely on when it give output. So we just doing something, and our order state machine processing it, what it's doing without waiting for event from that worker specifically. For example, like sending email here like that. So for example, here when we order paid, our worker doesn't reply with a new event. So such thing like that can be asynchronously without order of like whole this transaction. All other thing like here, as you see, I have numbers here, 1, 2, 3, 4. That means that they running in such order. There should be no possibility that they can run in different order. And that's basically a state machine. In such way, it's very simple to handle all this event-driven architecture, because many developers struggles to run it and deploy it in production because they basically fail making state machine of their process. And before starting this thing like in developer role, you should fix it by the business pipeline and understanding how this should correlate with the business processes. So you should first align business processes and then move them to your application. So you don't have any problem with building state machine, and make it very observable for developers and support. So that's basically all what I want to show you. I will leave some links on the SRE workbook from Google on the non-abstract iterative design. Also some additional patterns like Saga and Outbox pattern. So if you don't know what is that, you can look at it. But the idea here is very simple. You start from small and create bigger and bigger, breaking some stuff on some smaller thing, or like they smaller but like bigger in group. So for example, first of all, we have just API server that was doing all the stuff. Then we move part of the stuff from the API server. Then we move another part of the stuff from API server. And in such case, API server is just API gateway. So it didn't process anything, just get request and send in response. That's all. So we just breaking our system on parts and asking question additionally on each component of the system, understanding if it works correctly, if there can be some edge cases that we need to fix before production. And then doing additional version of our infrastructure, of our architecture, of services, application, and stuff like that. In such way, we control what we're doing with understanding how long it can take, what problems can arise, and stuff like that. If you start doing this thing like from the beginning, like whole system, it can be really hard to understand all these questions. Some of them can be missed, and you get problems in the production with your users, with payments and other stuff. So that's why we're doing that iteratively. Also, if you look on the business, then you understand that business also iterates in the same way how architecture doing that. So you start with a small business, then you add additional workers, you become bigger, and bigger. And while business becoming bigger, your infrastructure also becoming bigger, because development different application, it just we're doing that for support in business. So we can't have small application and not very good for big business. So if one grows, then another also grows. And iterative design doing that, align it to the business needs. That's the main idea here. I hope this was helpful for you. So please set likes, subscribe to our channel to get more interesting stuff. And hope I will have time to do more interesting thing here. Also, I'm building some course on system design, and I hope finish some part of it before ending of this year. So I will also notify you about that. I hope it will be interesting, because it will be aligned on the senior developers to give more practical thing, not like just lecture. And gives like my experience, possibility me to give you my experience with some practical advices and practical ideas. So, for example, one of the first things that I want to do, it's create a login server that should be fast enough to compare with, for example, Grafana Loki, and that another like requirement for it, it should be very cheap in saving the data and requiring the data. So that will be one of my practical courses inside all the big course of system design. So as I said, please set likes and subscribe, guys. Thank you for watching. Bye.